and welcome to live stream number 40. Today is August 3rd, 2017. I hope you're doing well, and thank you so much for taking the time to join today's live stream. If you're watching this, then you are watching the recording. Go down in the description area. You will find my email address, lars.christensen@autodesk.com, and shoot me an email if there's any specific topics that you would like to see. Now, we should hopefully have a few people joining here in just a second so we can get on with today's topic, what is to stop collisions with your tool holders and your tool and your vices and so forth. Now, I can see we got people in here. We got Jacob in here. Sanjay, good to see you. We got Anshay, maybe that's how you pronounce it. Now, I gotta apologize for the last couple of days because the live stream have been very static, had a huge lag, and I hope that's not the case today. A couple of things on my end. I think that maybe it's all my fault. I think that my Dropbox was syncing yesterday and the day before. But you let me know if I'm all robot like chopped up. Then we're gonna just have to figure something else out. I also moved some lighting and some microphones here today in hope that you get the best quality you possibly can. You let me know in the live stream. If it's in the live stream, let me know, or in the comment area below. This is really an attempt to try to add some value to you, and there's nothing worse than when it's all lagging and jumping around. So we definitely got to try to eliminate that. All right, live stream number 40. Really appreciate you guys taking the time. Let's jump into today's topic. Now, today's topic is all about CAM. So if you're not into CAM, take the day off. So we're going to talk about collisions inside of Fusion 360. This is probably one of the most important things you can do when it comes to programming inside of Fusion, is to take the time to simulate, go through the simulation, and kind of get. This is really the eye out to what is going to happen out of the CNC machine. When you actually execute the program. So this is kind of like, I like to call it like looking into the future. You got a couple of different options in here in the simulate. Be aware of. There's an info tab over here that I think many people miss, where they actually show you the position, spindle speed, and what operation is running. That's really handy. Also statistics that kind of like give you how many tool changes, and of course the machining time. And my experience is the machining time inside of Fusion is actually pretty accurate. So make sure that you definitely pay attention to that. Now, another thing I like to do in the drop down here on the mode, I actually like to normally look at it with what is called tail, which is kind of like it shows the beginning and then it kind of like just fades away so I can see the tool. Of course, it is also valuable to add on the stock can be nice too, so you can actually see things being removed as you're machining. But sitting through the simulation here is extremely helpful. And there's actually one here called Stop on Collision, what we're going to talk a little bit about today. Now, back in the day, I used to program some different CNC machines, and some of them actually had like multiple fixes. So I did a lot of like tombstone machining, where you can fit 25 parts or so, or even more on one pallet. What means that this whole thing about simulation can get a little boring, like watching paint drying. Like you're just sitting there for like, I have definitely sitting for 45 minutes with my cup of coffee in hand and just watched as the tool kind of like makes its way through this whole thing. But I cannot say enough. That is worth your time, because if the machine crashes, awful noise, boss comes running, it's horrible. So what I wanted to talk a little bit about today is some of the great feedback you can get when you are working in here. So for example, if we go over and we look, let me just go through here. If we look at this tool right here, so if we look at this circular tool path here, we can see that the cutter is going actually it's going past a little bit down here. Now this is actually an old program that I programmed a while back, because you can see we don't have a tool holder in here. Now let's go ahead and edit this tool. So I'm gonna go in and hit select, and we could select pretty much whatever tool we want. I'm just gonna select, I think I have a short 1/2 inch end mill right here. Hit OK. So now we can kind of like see the holder here, and let's hit OK to that and just see what we get. Now you will see that if I only have this tool path highlighted and I go into simulate, you will see that we do get a lot of, we do get some collisions down here. And they can many times happen because of what happens prior. Because I only had this toolpath selected, Fusion don't have a chance to know what all the other toolpaths would do. So what I recommend you doing is you go back up to setup and select that, and then hit the simulate button. Now it want to start all the way up at the top and work its way through all these, but of course you don't have to wait for that. You can actually just select that tool path here, and it will speed right to that selection, and then you will have cleaned up any specific collisions that could have happened prior to that. So that is definitely a best little practice there. I'm just curious, guys. You guys are sitting in the live stream. Are we all choppy today, or are we kind of good with the stream here? Because yesterday and the day before we had some terrible lag. So if you would send me a comment about that in the chat, would be awesome. All right, moving on. So go down here and select, and it will jump right to that tool path there. Now you will see, as we're looking over in the stream over, some of you guys already know what this means. See all these red lines down here? That shows me that there's some collisions. And actually, if you hover over them, it will actually show, it shows here collision 1, shaft collides with stock. So read this because it gives you some information. The next one, circular 3, let's see here, collision 6, holder collision with stock. And you can actually just go right, if you left click with your mouse, it will take you right to that moment. And when I simulate this, you will also see that we get an indication on the screen here every time that there is an issue. It goes red, right? This is when, in real life right now, sparks will be flying. Terrible. Yeah, you know, the boss is coming running. So this is the indication right here. Let me just pause it here. This is the indication right here that we are hitting. Now, so here in this here, it says shaft colliding with stock. What, of course, is maybe enough explanation. But another little trick I want you to know. I paused my simulation here. You can zoom in really close, and then if you hold down the left mouse button and you start moving your mouse back and forth, now it's going to update all the time. But you see how by holding down my left mouse button and move my mouse, I can control, and that can be extremely helpful just to kind of like see where exactly does it happen. So this, you have to look out for this. You have to take the time, to do these things. Now, if you're just machining around a simple block, you might not worry too much about, setting up your tool length, because that's this here. If we go and look at this specific tool, let's go back in and look at that tool again. Of course, the information for this tool is all coming from this page here. So I went into the tool library, right click, hit edit tool. And all this information over here is, of course, what gives that feedback that we are hitting with the shank of the tool, or we're hitting with the tool holder. Now, if you're just machining around something and you know that you're all good. I'm not saying that you have to set all these things up, but if you're setting something up where you're relying on, you know, getting this kind of feedback, take the time to put in the right information in here. Um, that that's definitely a good advice. So take your time to set up your tools. If you and take the time to watch your simulation to make sure that you see any issues so you can address them before you're standing out of the machine where many times it's too late. Now, another thing that you need to be aware of if you're not is, so the collisions we just see on this specific tool, we are seeing on the part. Now, this is an assembly right here that we are machining. But as you probably have noticed, that all the toolpath for this is only looking at the part, not devices, the table, and other things. That is done in our setup. So originally when we set this setup up, I'm going to go up and right click and edit that. We specified in here that this is the body. Now be aware of that right underneath that there's something called fixture. And if I select fixture, I can actually select certain items that I may or may not would be concerned about when it comes to simulate this toolpath. So for this part here, all my toolpath was really considered around the inside of the part. But what if I wanted to machine the outside, right? I mean, like many times you get a piece of stock that is too wide or too long, and you got to machine around it before you flip it over. If I select the two jaws right here, and this is in the setup, down in the bottom, check fixture, select your two jaws, and of course right now Fusion is like, what the heck? We see that there is we changed some things, we got to regenerate, and you can just do that. Right click, say generate toolpath, and it's going to do that. But if I applied a contour toolpath to machine the outside, so let's do that. So 2D, I'm going to go and select contour. Let's just go ahead and select that same tool we just used, the 1/2" flat end mill, hit OK. And let's go and select a contour selection. Now, I could select the top, but because I kind of like have these cutouts down here, I don't know if you can see those really well, I'm going to select the bottom. Okay? Now, if I'm just in a hurry and I don't think about it, I might just hit OK and think that I just made a pass around the outside of this part. And if I'm simulating it just by itself without paying too much attention, it might look pretty good. But you know that there's going to be a collision. Now let me just go, actually let me go back into the setup and uncheck. So I'm going to go back to the setup and uncheck the fixture like that never happened. And let's just regenerate that toolpath we just created. So what we have right now is this. Okay. Now I get some warnings, and you can see that the tool holder goes red. Let's just go down and click on one of those lines, and I can see that it says that the shaft collides with the stock. So that tells me that if I go in and edit this end mill, right click, hit edit. If I go in here and I say, well, you know what, I am going to make the flute length 1.5 inches and the shoulder length 1.5 inches. Well, let's just make everything 1.5 inches. Like that is a flute going all the way up there. Yes, sure, whatever. And let's hit OK to that. So now we know we have plenty of flute length. I got a color that was long enough. Now it looks pretty good, right? Except, of course, you can see we're flying right through our jaws. I hope you can see we're flying right through our jaws. But we don't get any warnings down in the area down here right now because we're not colliding with the tool or the tool holder. Well, that is where right-click on your setup, edit, and if you turn on your fixturing, you can actually take external components such as these jaws. It could also be like a fixture plate you have underneath or something. And now when I generate that tool path, you will see that when I simulate that, you will see I don't get any red down in, oh, here it comes. Just took a second. You will see how the tool holder, I'm going to keep playing it, it turns red on the face where it's going to hit the jaws. Red, normal color, red, normal color. So it gives you this visual idea. Stop on collision. Right? See that? Now it actually gives you a stop on collision showing you exactly what is happening. So a couple of things to take away from this. One is right click on my operation here. Make sure that when you set up your tool in here, and this is why I recommend, I always recommend that you set up the tools that you have on your shop floor. I actually have a guy who emailed me last night asking for my tool library. I don't mind sharing my tool library with you, but it really defeats kind of the purpose because you bought your tools with your tool holders and kind of like depending on what type of machine you have, the feeds and speeds you can run. If I give you my feeds and speeds and my tools, that's not what you have. So build up your own tool library. Definitely recommend that. And by the way, if you want more about the tool library, where we're in here, one of the live streams, we talked about this too. So go and check that out. Ooh, looks like we got some spamming in the live chat. Oh, that's a first. Great. All right. Anybody need any male enhancement products? Then check out the live stream. I think we're good. We're good. So make sure that it's just, I love doing these live streams. This is just too funny. So make sure that you set up your tools right in here. And then second of all, make sure that in your setup in here, you can go in and edit your setup and you can turn that fixture on. So that is definitely important. Now, the last thing I want to show you, I think is absolutely awesome. I owe somebody on the development team a beer or a case of beer or something like that for that. Let's go and look at this model right here. Hang on. Maybe not. Okay, looks like I had a little bit of a lag there. That's okay. We'll just find something. Let's go and look at this one here. Open up this one. That gives me a chance to grab a drink. Okay. So here have this layout. This is a webinar. There was a webinar I did a while back for Modern Machine Shop. I was talking about utilizing work holding on your machine, and if you didn't watch that webinar, if you're interested in whole work holding and how you can optimize the setup on your machine, send me an email, lars.christensen@autodesk.com, and I'll try to find a link to that webinar. I'm not quite sure actually where it is, but over here on this part over here, this is kind of like a 3-axis part. Let's just go into the cam. And I'm pretty sure that it is this last setup here. Yep, we got a toolpath here. All right, let me delete the toolpath in here. So if I go in, so we got the full setup sitting right here on this block. If I go in and I add a 3-axis adaptive on this part, so I'm just going to leave it at a 16 flat ML. Doesn't really matter. Now we talked a little bit about selections recently with the machining boundaries and those things, so you can find that live stream if you're interested. On the heights tab here, it's set to the bottom of here, but actually I will set selection and I will select this bottom face because I don't really want it to machine further than that. Let me hit OK to that. And we get what looks like a pretty nice roughing tool path around this part. Now let's go ahead here and simulate it because that's really what matters. And as soon as I do that, look what happens down in the tree. I actually get collisions. So it says here holder collides with stock. Holder collides with stock. It looks like we have some different. Well, let's look at it because that's one of the nice things too. Now I have stop on collision checked here. So let's just go in here and it starts machining. I'm going to speed it up a little bit if I can. Goes a little bit faster here. And we should see in just a, well, it'll come to it around over here. Let's speed it up to that section. Right there. So what happens right here in this collision is that the tool holder is actually hitting the stock that is left from a previous operation. And if we go on, I don't think I can if I have a stop on collision on. Check that. If we move on, turn collision on again, you will see that it happens again over here on the side. I hope it shows up. And again, this is not cool, right? Like sparks are flying, hit the emergency stop and all that stuff. So of course, at this point, we could do what we just saw before. We can go into the tool library. We can start to come in with a longer end mill. But because this is a 3D tool path, there's actually a pretty cool function in here. If I right click and go in and edit this tool path again, down at the bottom, this is where I need to send, I don't know, some Danish beer to some developers. There's something called shaft and holder detection. I click on that, and when I do that, you will see here that I have a couple of different options. So there's one called detect tool length. Then there's a nice little screen here that has been created. There's one called pull away and fail on collision. Now, fail on collision just means that if I check that and I hit OK, that it will start calculating it, but then it will actually fail and just give you the red dot saying, hey, there's no toolpath in here, it failed. So that's decent. But the two other options I think are really interesting. One is called pull away. So pull away, you get a shaft clearance and you get a holder clearance. Now if I say pull away and hit OK, it will actually generate the tool path, but you will see when we get to around this area here, I gotta regenerate it. When I get to about here, the tool will kind of like move out. So edit, pull away, hit OK. There we go. Oh, it looks like I got a little bit of lag. I hope that's... Oh, here comes that warning. Okay, never mind. Edit that, pull away. Huh. Let's try to turn it off for a second. All right, so here we can see the standard toolpath where it comes to here. And let's go in and try to turn it back on. Say pull away, hit OK. Oh, and for some reason it won't. Is that because my clearance is not that tall? Pull away. Give it a little bit more shaft clearance. All right, that's typical. That's why I like to do this live. It's always good. All right, I'll do this one more time. Hit OK for that. Turn on shaft collision, detect the tool length, or pull away. Hit pull away. And show log. No holder geometry. Oh, it looks like maybe. Is that because of the tool? Let's try this one. That was the one we used before. You know what? That's because I had an older tool holder selected. Okay, so you will see now. Hey, we get whatever we get, however we get to the result. I'm fine with it. You will see now the toolpath comes down. See how here, how it actually starts moving out. So the pull away is smart enough to know that when it gets down to about the end there, that it's going to collide, and the tool will pull away from the part, and then of course you have to clean that up with another tool, but pretty cool. Now the last one I want to show you in here is then the detect tool length. The detect tool length, it would actually find what is the minimum length but without colliding, and you just saw here how the tool actually got extended out of the holder. And then you do get a red flag over here, a warning. This is not bad, these yellow ones, just giving you a warning. And if you right click and you go down and hit show log, you will actually see that it's going to show you how long it pulled the tool out of here. So I hope that this here is helpful. It looks like I do have a little bit of a lag. I hope that it's just in here and not on your end. Yeah, so that was what I was planning on showing today. I can see that we got, looks like a lot of spam in the live stream. That's not cool. That have never happened before. I hope that that is not going to be something occurring. But I hope that this was helpful. So definitely, I beg you, please make sure that you take the time to look through your simulation. And if you set the tool links to the right thing, the fixture option in your setup, and then if you're doing 3-axis, how you can actually control the tool length and how that's going to behave, that will give you some options to make sure that you don't crash your machine, because nobody liked that. All right, I'm not going to try to go in through the live stream right now, as this, if somebody's watching this from the recording, because I can see I got to sort through some of this stuff that was going on. Kind of sucks. But I definitely appreciate, there was 53 people in here, definitely appreciate all you guys taking the time to join these live streams. Tomorrow's topic is a good one. Tomorrow, we are going to talk about how to put tolerances and how to create clearance of tolerances and clearances when it comes to 3D models. A lot of people have asked me, especially if you do the absolute beginner one, how would I go about adding clearances to that lid that fits on it. So tomorrow we're going to talk about in the CAD world, how do we deal with tolerancing and with clearances and so forth. So that's tomorrow at 3 p.m. same time as today. I'm going to end the broadcast right here, and then I'm going to jump into the live stream because I know that we have some cool people in there, and I got to go in and say hi and see if there's any questions. So until the next time, I hope you have an awesome day. Again, thank you so much for watching. Thumbs up if you like it. Be honest, thumbs down if you don't. And I hope you have an awesome day. Thank you so much, guys.